All right. So today we're going to be starting on page 152, number 2. I want you to title today's notes Thursday, November 4th. Go ahead and do that right now. All right. So start by looking at Sherry. She's working at the same credit card company. She calls existing customers to sell them additional services for their account. All right. So Barry from our example from yesterday, he's trying to create new accounts. Sherry is just adding more products on top of the account that's already there. All right. So, for example, if you have a checking, do you want to open a savings account? If you have a home mortgage, do you want to get a car loan from them? The next table shows how much Sherry earns for selling selected numbers of additional services. So, does Sherry daily appear to be a linear function of the number of services sold? Explain. All right. To me, it looks like it's a linear equation, right? Because we can look at it, and if we notice, as we're going up on the daily pay, we're increasing by the same amount. We're increasing by 20 every single time, right? And as on the top two, right, the number of services sold is 10. Or another way of saying this is our rate of change isn't changing; it's staying the same. So we can say that it is. We can say it appears to be Sherry's daily pay appears to be linear. All right, so why? The pay increase, we could say the pay increase is the same. Same because for every, you don't have to write it exactly like this, for every 10 services sold, her pay increases by $20. Right? So remember, that's like our constant rate of change. This is what we're looking for when we're talking about constant rate of change. We want it to be very same, like it's got to be the same every single time. We don't want our rate of change to change. Okay. So again, you don't have to write this as many words down in your notes. This is getting you ready for the quiz. These are the types of questions you're going to have to answer. So make sure you understand the question. Okay. All right, so number 2, part B. So assume that Sherry's daily pay is a linear function of the number of services that she sells, and calculate the missing entries in the next table. Right. So we have our table here. These are the numbers that we already have. So let me zoom in. Right, we want to try and figure these out. Right. So again, for every 10 services that we increased by, our pay was increasing by 20. So if, for example, we cut that in half, we increase by 5. My increase should be cut in half. So instead of 20, we're going to increase by 10. So 60 plus 10 is going to be 70. So if Sherry sells 15 services, she'll make $70. We can do the same thing for 25, right? So instead of increasing by 10, we're increasing by 5. So then we can see that plus 5. So I would increase by half of 20, which would be 10, or $90. And we already know the 10, right? So if I increase by 10, I would increase by $20 as I'm going up. You can see that when we go from 10 to 20, 10 to 20, and 60 to 80, right? But if I decrease by 10, so now I'm going to be subtracting, let's go this way. So minus 10, I have to subtract 20. So instead of being 60, I'm going to only make $40 if I don't sell any additional services for that day. Okay. All right. So if we increase by 10, we're getting 20. And so if we increase to 60, we'd be at 160. So if we had like 60, let's write this out. If we had 60, 140 plus 20 would be 160. If we had 70, this would be 180. If we had 80, this would be 200. 90, I'm just increasing, right? You can see plus 10, plus 20. This is what we saw in our last chart, right? So we're talking about 10 to 20 was 10, and then 60 to 80. 10 to 20 was 10, 60 to 80 is 20. So I'm just constant rate of change. So this would be 220. All right, so then 100 would end up being 240. Cool thing about this is we can start to also see, we can reduce this, right? We talked about tens, we can talk about the number of services increased by 5. We talked about them decreasing, but if we want to keep it the same, we want to figure out how much we're increasing by 1, we can simplify this, right? So if we had 20 increase over 10 services, 20 divided by 10 is going to end up being 2, right? So for every 1 I increase on top, I'm going to increase, I forgot to write this number down, right? That was our answer for here. So if I increase by 1 here, I need to increase by 2 here on the bottom. So it'd be 242. Okay. Going to pause here and let you get caught up. All right. All right, so we're going to talk about another type of table, right? So the key feature of any function is the way the value of the dependent variable changes as the value of the independent variable changes. Notice that as the number of services Sherry sells increases from 30 to 40, her pay increases from 100 to 120. This is an increase of $20 in pay for an increase of $10 in the number of services sold, or an average, that's what we were doing. We wrote 20 over 10 and we divided that, of $2 per cell. Her pay increases at a rate of $2 per service sold. Using your table from Part B, study the rate of change in Sherry's daily pay as the number of services she sells increases by completing the entries in the table, like the one below, right? So I want you to make sure you write this table in your notes. So if our change in sales is from 10 to 20, where our change in pay, right? So if we're going from, let's go and flip back over here. From 10 to 20, went from 10 to 20, we went from 60 to 80. That's an increase of $20. So I want you to write $20. If I go and write the rate of change, I can say 20. My change in cell is 10, right? So we can say 20 over 10. That's going to be equal to $2 per cell. Right? So again, let's go 20 to 25. Let's take a look at that. Changes in cells from 20 to 25. We went from 20 to 25, I'm increasing by 5. My pay increase was $10. All right, so if we increase from 20 to 25, my change in pay was $10. So I can write my change in pay on top. My independent, so the number of variables, the number of cells was going to be 5. So again, 10 divided by 5 is going to be $2 per cell. So let's do 25 to 40 now. All right, let's take a look. So we had 25 to 40. That's an increase of 15 on bottom, an increase of 40 on top. Let me make sure I'm doing that right. Oh, sorry. Now we're going from here. That's 15, and then we're going from here to here. That's an increase of 30. Sorry. I was looking at the wrong number. So 30. So let's go and write that in our table. Right, we're increasing by 30 on top. We're doing 30 divided by 15. 30 divided by 15 is going to be $2 per cell one more time. And we're going from 50 to 100, so we know my bottom number has to be 50. We went from 50 to 100. We went from 140 to 240. So it's going to be an increase of 100. So our number of money increased by the amount of money we earned increased by 100. So we're going to do 100 divided by 50, which is going to be, again, $2 per sale. All right, what do you notice about the rate of change in Sherry's daily pay as the number of services she sells increases? It's all the same, right? You can see that right here. They're all the same. It's all going to be $2 per cell. So again, we can say, just like we said earlier, I think that was in question, we can look from looking at the table, it looks like it's a linear pattern, right? It's a constant rate of change. All right, so we want to first start, we want to write a now next rule. So remember, our framework for our next now rule is going to be next equals now. All right, so how much are we increasing by? We're increasing by $2. So we're going to say now plus 2, and then we're starting at where are we starting? If we look at our table, let's go all the way back. We're starting at 40, right? When our independent variable is 0, our dependent is going to be where we start. Right, so that's what you want to write. Make sure you know how to do this. This is going to be on a quiz. I'm going to consider the following rules now. So we have rule 1. We have all these rules. Which of the rules show how to calculate Sherry's daily pay for any number of services N she sells, right? So if we look at each of these, if I were to plug these in, so let's take a look at rule 1. So we have C equals 2 plus 40N. If I plug in 0 for N, erase that, I would have, let's see, this would be 2 plus 40 times 0. So that'd be 2 plus 0 times 40 is going to be 0. So when N is 0, let's look at our table. When this is 0, our answer was 40, not 2. So this isn't going to work. Let's take a look at rule 2. N plus 2, right? So C equals N plus 2. So when N equals 0, we're going to have 0 plus 2 equals 2. Again, we want our amount of money to be 40, right? We're trying to match this to our table now. So that doesn't work. So rule 2 is out. Let's do rule 3. So 40 plus 2n. So C equals 40 plus 2n. And when n is equal to 0, we'll have 40 plus 2 times 0. That's going to be 40 plus 0, or 40. Okay, that could work. Let's check another number, right? So when n is equal to 10, we can have 40 plus 2 times 10. So it'll be 40 plus 20, or 60, right? Let's take a look. Yep, that works. Okay, all right, so we checked a couple points. This is going to be one of the ones that works. I'm going to circle that. It works. Let's check the other ones. So rule 4. So we have 50 plus n divided by 2. So C equals 50 plus n divided by 2. If I plug in 0 here, so we have 50 plus 0 divided by 2, which is just going to be 50 plus 0, because 0 divided by 2 is just 0. And this will end up being 50. Well, that's not right. So again, rule 4 doesn't work. Let's check the last one. C equals 2n plus 50. So when n is equal to 0, we'll have 2 times 0 plus 50. So it's going to be 0 plus 50, or 50. That, again, doesn't work. Cross that out, right? So which of the rules show how to calculate Sherry's rule? So this is going to be rule 3. And if you want to show how you know, like this is how you check it, right? We already showed our work. I'm going to zoom out a little bit. This is how I would show my work, right? I'm just looking for, I would show my work by, here's rule 4, sorry, rule 3. I would plug it in. Basically, that's what we're doing. We're plugging it in. Right. What do the numbers and the rules you selected in part 1 tell you about Sherry's daily rule? All right. So if we take a look at this number, right, this was our rule here. Remember, this was our starting amount. So the 40 is going to tell us our pay with no cells. And the 2 tells us our pay per service sold. right? So these are the types of things you need to tell me if you see a question like this on the quiz. Okay, we got one more problem we're going to do today. All right, so the diagram below, the diagram shows graphs of pay plans offered by 3 different banks to employees who collect credit card applications. Match each function rule with its graph, right? So we have Atlantic, Boston, and Consumers Bank. Explain how you make the matches without calculation or graphing tools needed, right? So we're not going to do any calculations, right? We're just going to look at the numbers here, right? So that number, remember that number by itself, that's going to be the number that we are making without selling anything. And that's typically going to be where we start. So when we see 20, Atlantic and Boston could be one of the 2 numbers that start at the same place, right? They both need to start at 20. So if you notice, I have these 2 have the same starting point. So I could say this could be I, right? So this could be this one or 3 because they both have the same starting point, right? What we need to do now is we need to look at the next part, right? The next part tells you how much you make per sale after that. So with Atlantic, my increase is $2. So I'm making $2 per sale. And you can see that the Boston, if you go to the Boston Bank, you'd be making $5 per sale. So you're going to be making more per sale. So my slope is going to be a little steeper, right? You're making more money. So my Boston Bank would be graph I. My Atlantic Bank would be graph 3. And the Consumers Bank, which had the higher starting point, you can see how my higher starting point was right here. This would be graph number 2. All right, last one. What do the numbers in the rule for the pay of the Atlantic Bank tell you about the relationship between the daily pay and the number of credit cards, number of credit card applications collected, right? So we look at just the Atlantic one. We're just looking at this bank right here, right? So remember the numbers tell us, right? This 20 would be our pay with no application sold. This number, this 2, is going to be the price. No, not price. This is going to be our pay per sale. Per application sold. All right. From here, I want you to work on Delta Math. If you go over to Delta Math, let me go ahead and pull up really quick. Got some practice. I added a couple things. We're going to plot. We did this one from yesterday, so I added 2 more groups. We want to find the slope graphically, and we want to graphing lines from equations, right? We're getting a little bit of practice. If you have not finished the Unit 2 test, make sure you get that done, that turned in. If you want to retake the Unit 1 test, make sure you do that. If you want to retake the Unit 1 test, make sure you email me. If you have any questions at all, please email me. I will see you later. Have a great night, a great day.